So today I'm going to show you real quick how to do all of the measurements that you're going to need to do on this board, and not that I am going to show you all of the assignment. I'm just going to show you how to do each of the measurements. There are multiple that you are going to need to do above and beyond what I show you. So we're working on the brake light trainer right now. I'm going to show you how to do voltage measurements, amperage measurements, and resistance measurements. We'll jump right into voltage. We have our power supply turned on over here, and I'm going to take my black lead and my red lead. We have our battery down here. I know it's kind of covered up, but battery, negative and positive. I'm going to take my black to negative, my red to positive, and we have 13.83 volts provided to the circuit to feed everything that is here. Next, what we need to do is we are going to measure voltage at a component. And to measure voltage at a component, we're going to put our black lead on ground, battery ground, as close to battery ground as we can. In talking real world stuff here, or not sitting at a trainer, but in this case we can get it right to the battery ground. And then we're going to touch parts of the circuit. Now realize there are going to be parts of the circuit, if we go up to like this, comes in and goes up to here, I can measure voltage right here because there is always voltage sitting there. When we get down to the lights, there is only going to be voltage provided to the lights if the lights are switched on. Okay, otherwise we don't have any electrical power there. So it totally depends on the circuit that you're measuring, how you need to measure that for voltage, if the circuit needs to be on, or if you want to see if there's even voltage getting to parts of the board or vehicle, then that's going to determine how the circuit needs to be on or off, or where you're going to be measuring from. So in this case, we're going to measure voltage at a location, and we'll do the left brake light here. We have our red wire here coming in, and in order to measure voltage here, you'll see we don't have anything. So that's what I was just talking about. We have power to parts of the board, but we don't have power to here because it hasn't gone through the brake switch yet. It's stuck. If I measure up here, it's stuck at the brake switch. It's not getting through the brake switch. So in order to get power here, I need to push the brake pedal. I'll do that with my arm. And we are getting 11.3 volts provided to the power side of the bulb. Now for voltage drop, we're going to measure with our red and our black lead right at the component. So we've got the wires coming out of there, going up to here, and we will measure right at the component. Again, it's got to be on to get voltage, especially to get voltage drop. You're not going to get voltage drop without current flowing. So the light's got to be on, and we get 11.1 volts being used by the brake light. Now this is a trainer issue. The switch is kind of sticky, but so 11 volts being dropped at the bulb. That is actually a problem, but it's a problem for discussion for another day. Okay, so that's not as much as there should be. We are getting voltage drop places on this board we shouldn't be getting voltage drop, but we will discuss that further another day. Right now, we are about 11 volts, 11.08 volts being dropped by this bulb itself. Okay, so that is our voltage measurements. We've got our voltage at measurement, and we have our voltage drop measurement. Now we need to go to resistance. We'll do resistance because we stay in the same port here. We're going to keep the red in the volts and resistance port. Now to measure resistance of a component, we will do the left brake light again, and we just need to loosen these up. You do not need to take the screws out because the style of clip here that we have, connector and terminal that we have, they just pull out when you loosen them up. So to measure resistance, it doesn't matter where your leads are, you're going to get the same measure on either side, but for the sake of keeping things looking organized, I will keep red to red and black to black. And then I'm just going to touch both of those leads. You want to make sure not to touch the components because you can throw off the resistance measurement potentially, but then also you want to make sure that you don't just leave one of them connected, because that can potentially also throw your measurement off. Disconnect both wires and measure just the bulb itself. Okay, so we're looking at about 0.7 ohms or so on that bulb. Moved around a little bit, but that's about where we are. That is our resistance measurement. I'm going to put these back in here. They don't need to be super tight. Don't reef them down. We don't want to break any of this stuff off. Okay, and just snug it up. Now we're going to do our amperage measurements, and for that we've got to put this down on the amps DC. We need to take our red lead out of the volt and ohm port and put it in the money port, the amperage port, and now we have a wire right here. We cannot go across a load right now, so if I was to turn that on and touch both of those, we're going to bypass this load, and all of the current is going to go through the multimeter and blow the fuse in there. Do not do that. So what we're going to do now is I need to disconnect one wire. It doesn't matter, power or ground. In a series circuit, amperage is going to be the same everywhere in the circuit. Now, what I am also going to do is you always want to keep your red lead closest to the battery, And even though this is red, this is our power, this is actually coming from the battery through here to the bulb and then out to ground. So this post is closer to battery than the wire is. The wire is closer to ground, and we are going to measure this. Now, like voltage drop, we've got to make sure that the circuit is on, and we can tell that the measurement that I am making is good because right now one of the wires is disconnected, but the light is still on. If I remove one of my probes, the light turns off, which means that we are funneling all of the current through the multimeter leads, through the multimeter to be measured, and back to the circuit. Okay, so with that, we've got about 2 amps being used on this one light bulb here. Whenever you are done with amperage, take this red lead out of the money port and put it back in the volts and ohms port, and that way the next group that comes over, their first measurement they might need to take is going to be a voltage measurement, and as they go to do that measurement, they may not realize that the red lead is in the money port, and then they'll go to do their measurement and blow the fuse. Okay, so always, if you put it in the amperage port, you are responsible to take it out of the amperage port. Okay, so that is the measurements that are required for this activity. If you need any further help, please let Mr. Long know. He's here to help, but this video should cover everything you need. Have fun.